my name is Wendy Reed and I am a high school math teacher, and today we're going to learn how to set up right triangle trigonometry problems. First, I want to bring your attention to these words, or this one big word. The word is SOHCAHTOA, and that's a mnemonic to help you memorize your trig functions. The first three letters is SOH. What that means is sine of theta, theta being an angle measure, is equal to opposite over hypotenuse. That's what the first section means. The second section, the CAH, stands for cosine of theta is equal to adjacent over hypotenuse. And then you've got TOA, which stands for tangent of theta is equal to opposite over adjacent. And we'll get into what all those mean in a little while. But remember, theta always stands for the angle measure. Alright, so we use those to set up problems. First, let's talk about this right triangle. Of course, you've got the words opposite, you've got the words hypotenuse, and you've got the words adjacent. You're probably wondering what that means. You recognize hypotenuse from regular right triangles. So the hypotenuse is always across from the right angle. Here's your right angle, so my hypotenuse will always be across from it. But the tricky part is the opposite and the adjacent can change according to the angle measure. So, for example, if your angle measure is in your lower corner, depending on how the triangle's drawn, let's say your angle measure or your theta is here. Your opposite and adjacent are dependent upon your theta, okay? So, if my theta is here, opposite of theta will be across from it, and that side would be my opposite. Opposite obviously means across from or opposite from. And then adjacent means next to theta. So here's my theta. Next to theta would be here, and that's where my adjacent would be. But your theta is not always going to be in the same place. Let me draw another triangle. Say I draw a triangle like this. I'll draw the same one and then we'll just see how it moves. Okay? Again, your hypotenuse is always across from the right angle. So here's your hypotenuse. But if my theta is up here, now my opposite and my adjacent are going to change. So it goes from down here to up here. So now your opposite is going to be across from theta. So now my opposite is down here. And my adjacent is going to be next to theta. So my adjacent is going to be over here now. So remember, hypotenuse never changes, but opposite and adjacent can change depending upon theta. Let's look at one more triangle just to see it in a different light. Let's say I have a triangle that looks like this. Okay, a little bit different looking triangle. You always start with your hypotenuse. Hypotenuse is across from the right angle. So here's your hypotenuse. We'll put theta over here. Here's theta. Across from theta is going to be your opposite. Next to theta is going to be your adjacent. And that's how we label it. Let's look at an actual problem. Let's see. I'm going to change this one. Let's check this problem out here for a minute. Our objective is going to be to find this side length, x, okay? So what we're going to do is we're going to use these three equations, or formulas if you will, to figure out how to set up the problem for x. So the first thing you need to do is label your figure. It's not theta anymore, it's an actual angle measure, but this is your angle measure, or your theta. Remember, here's your right angle. Across from the right angle is going to be the hypotenuse. Here's your angle. Across from the angle is going to be your opposite, and next to the angle is going to be your adjacent. Now, you've got something for the opposite, and you've got something for the hypotenuse. But is there anything over here for the adjacent? No, there's not. So we really don't need it. So I'm going to take it away. So what we have here is opposite and hypotenuse. So you look over here, you look at which one uses opposite and hypotenuse. Well, that's opposite and adjacent, not what we got. That's adjacent and hypotenuse, not what we got. Opposite and hypotenuse is sine. Okay? So we know where you're going to use sine. So you use this little formula to set it up. So it's sine. Remember, theta is always the angle measure. My angle measure is 15. Is equal to opposite over hypotenuse. My opposite is x over my hypotenuse is 30. And that's how you set up the problem. But let's look at a couple more examples. Let's change this one. Okay, let's look at the above problem. As you can see, you've got just a regular problem. First thing you need to do is label. Okay? Across from the right angle is always your hypotenuse. Across from the theta or the angle measure is always the opposite. Next to the angle measure is always the adjacent. Okay? So we look. We don't have anything for opposite, so we really don't need it. So I'm going to take it away so it doesn't confuse us. We've got adjacent and hypotenuse. You look over here, which one uses adjacent and hypotenuse? Cosine does. So we use cosine. Cosine of the angle measure, my angle measure is 32, is equal to adjacent, which is 15, over hypotenuse, which is x. In the next video, we'll work on solving these problems. At the moment, we're just setting them up. Let's do one more example. Alright, first thing we do is label the figure. Your hypotenuse is always across from the right angle. Your angle measure is an actual letter this time, so it's a variable. So opposite of the angle measure is going to be opposite. Next to the angle measure is going to be your adjacent. Okay. We don't have anything for the hypotenuse, so I'm just going to take it away. So now we have opposite and adjacent. So we look at the one that uses opposite and adjacent. That's tan. So we use tan. Tan of the angle measure, and this time the angle measure is actually x, and that's okay. The angle measure can be x. Is equal to opposite, which is 10, over adjacent, which is 15. And that's a tan. And that's how we set up right triangle trigonometry problems.